And this is a short presentation about Neo4j graph database. So this is me again, and Neo4j. So these are some links, Wikipedia. You can download and install it because they have a community version. And unless you need a distributed enterprise with backing up online and have ultimate performance, then actually you can run it for free. So it's a completely open source. So it's a graph database management system developed by Neo4j since 2007. First version in 2010. So we're talking about what, 14 years. And it stores nodes, edges, and attributes of nodes and edges. It supports transactions. There is a community edition which is open source. And there are some advanced features which are in closed source commercial license. It's written in Java, that's why it has this 4J at the end. And it uses its own query language, which is called CQL, Cipher Query Language. And you can send the requests via HTTP protocol, or they have their own binary bolt protocol, right? So you can deploy it anywhere. It has a lot of different tools, development tools, workspaces, graph visualizations, and so on. And there are several clients in several ways. So it's developed very well. It's very convenient. So I want to say that there are many different types of databases, right? There are relational SQL databases, there are NoSQL, columnar, key value, document databases, and graph. So today we're talking about graph. And here are examples of screens of different tools. So for example, there is a client which works in the browser. There is a client which works as a desktop application. There is Neo4j Bloom. Well, this is a really great tool because you can color code different nodes based on their properties, and you can move things around. It's quite like animated. So these are examples of using a Cipher query language. I made the list of 20 different examples. How would you create a node? For example, you created a person with a name and age. These are properties. Create a relationship between two nodes. You see, this is actually their relationship, right? Find a node by property, update nodes property, and so on. So these are examples. We will not go through them. And again, there are good tutorials on YouTube everywhere. But you see, it is kind of similar to SQL, but at the same time is completely different because you have to deal with nodes and edges, which is connections between nodes. And by the way, the database, it may have node which is not connected to anything, right? Or it may have nodes connected to each other. The node may have direction. There may be multiple connections between nodes. So it's very flexible. Storing and querying embeddings in Neo4j. This is new. This is recent. I think it was in August. Yes, in August 23, they added native vector similarity search. So they had a property of a type vector before. So you could have a vector, but now they added similarity search. They used Lucene framework, which is written in Java, and Neo4j also written in Java. So they work together. And yeah, and you can just find, let's say, first like top using similarity search, top matches. So Neo4j vector indexes are powered by Apache Lucene indexing and search library. It's very fast. It implements hierarchical navigable small world graph to perform approximate nearest neighbor search. Vector can be stored as floats or doubles. Well, I think floats is enough. It's even more than enough. But depending on the syntax you use, they may create doubles, so you have to be careful. And hello? Do you hear me? Hello?
Yes,
Yes,
yes.
yes,
Yeah,
yes.
thank you, sorry. Okay, so this is example how you create a vector index, right? And then you do search by doing a call querying a particular index. So in this case, the index is called products. You search for 5 top matches using this property. Not property, sorry, using this vector. Uh, anyway, oh, this is thank you here. And what is here? Oh, okay, I'll move it to the end. No, come on. So next is scaling. Okay, Neo4j. So there is an enterprise edition which supports distributed architecture, multiple servers. You can partition manually or automatically. Interesting that it cannot run on top of AWS buckets. So it has its own system. Well, you can use AWS to store backups in there and then restore, but for running, it needs its own servers with its own files. The minimum server looks something like this, right? Which is absolutely reasonable server, very, very small one, in fact. So this is example capacity planning, right? So let's say you have 200 users, 75 million nodes, approximately twice number of relationships, 150 million relationships, 5 properties per node, 2 properties for relationship, about 200 queries per second. Indexes, well, let's put 20% of the size for indexes. And you can estimate disk space will be about 40 gigabytes of all these numbers. And we need the server. So let's say 20 virtual cores and 100 gigabytes RAM. Not a big deal. I mean, you can probably get it for about $2,000 a month, something like that, maybe even less. So that's okay, that's reasonable. But then let's say you're adding an embedding vector. And it has this dimension, and each of those has 32-bit, I mean 4 bytes. It's a standard float precision. So suddenly you're adding 6 kilobytes to each node, right? So now you estimate that you need 6 terabytes disk, and you need 3,000 CPUs and 15 terabytes of memory. So you cannot do it on one computer. So what do? You either need a distributed system, or instead of storing the vectors in the graph database, you store them in some other database and you sync them back and forth. So you end up having 2 databases. And there are databases which support 8-bit, 1 byte precision. So OpenSearch supports it from July. OpenSearch is from Amazon, right? But it's open source. Vespa, its own system, it also supports it. Apache Lucene, they supporting it starting November, but it hasn't propagated into graph database yet, into Neo4j. It probably will. Like Elasticsearch and OpenSearch are using Apache Lucene, so they should have precision soon. Well, actually, OpenSearch already has it, and Phase has support for compressing. Okay, so these are options. Installing Neo4j on Linux. So as usual, sudo apt-get update and sudo whatever. So these are operations you run step by step to do the installation. Not difficult, pretty standard. Everything works, and then default user is Neo4j, and you in business. And Neo4j from Python also look very simple. So you need a host. Let's say you will use HTTP protocol. You have your username and password, and you connect, and then you see run and result run query. So all looks pretty standard, the same way how you would work with other databases. Okay, this is it for today.